Okay. Hi, I'm Alan Said Lopez. I'm from group 602. My team is Francisco Crozon Torres, and this is our video for challenge number 9. The objective of this challenge is to design a mobile application that allows you to calculate the distance between two spots by knowing their altitude and length. Um, to do this, we have this app that when initialized, it will show a notifier that says locating chords like a loading screen. I'm going to refresh the companion screen so that we can see this. Locate chords. There we go. Okay. So, uh, our app. Does it send me send me to Africa? I think because I was doing nothing. Okay, we were thinking to do it better and innovate a lot on this challenge because we saw that we have maps on App Inventor, and we thought that it was going to be super useful for this challenge. And if we learn this already, if it was going to be easier on later challenges. So I'm going to do an example of the distance between two spots. Here on the first marker, the black one, it's on Tech Millennium. I'm going to drag it. Now we have the the it's hard, the longitude and latitude of the first marker, that is 22.12, and those numbers. It is not rounded up. I'm going to explain it later how does we do this. And then the second marker, there we go. My house is approximately here. It's not a good approximation, but now it's an example. So we drag those two markers, and now we have the distance between Tech Millennium and my house. That is 14 kilometers. I think it's very precise. Yeah, I think it's very precise. Okay. We can do this by using procedures. By using procedures, we actually use two procedures. We use a location sensor, two notifiers, and the map. So we have the location sensor that when the location changed, start two local variables, longitude and latitude, and set them to themselves, but inside the location sensor, so that the markers we can know the latitude and longitude of themselves. Specifically, our block says when location sensor 1 location changed, or do set global latitude to get global latitude, set global longitude to get global longitude. And then we call the map, the pan of the map, to the latitude and longitude, and set it to zoom 8, so that we have 8 of zoom. I think that's why it sends me to Africa. But okay. Then we have the markers. The first marker, when we stop dragging it, this is the first marker. I'm dragging it right now. When we stop dragging it, it will set the label 1, that is the one above the distance is, to join its latitude and space and its longitude. So we have 22.148 and minus 100. Then we set the label 3 to the distance between, it's hard to explain, to the distance between the marker 1 and the marker 2, being the marker 1 the black one, and the marker 2, the blue one. Now I'm going to explain the procedures, the main part of this challenge. We use two procedures. One with the formula shown in the class. I don't remember the name, but it's basically to calculate the distance between two spots, and another to round decimals. The first procedure, we call it Procallis. I don't know why Croissant call it like that, but okay. We initialize it with four, I don't remember the name, four variables on the procedure, four inputs, that was the name, to result of 100 times the square root of, it's hard to explain. Okay, first we assign D11 and D12, you can see it on our document, to the marker 1 latitude D11 and marker 2 latitude D12. We do D11 minus D12 and that to the power of 2. Then we added the other value that is longitude. We assign it D21 to longitude of the marker of the first marker, and we minus it, subtracted the D22 that is longitude, that we elevated to the power of 2. So we have the latitude of the first marker minus the latitude of the second marker to the power of 2, plus the longitude of the first marker minus the latitude or longitude of the second marker, and elevated that to the second power. Then after we got that operation, we do the square root of that value and multiply it times 100. You can see it clearer on our document because it's hard to explain formulas with only audio. And our second procedure, it's much easier. on our second procedure, we started two inputs and set it to result of the rounded result of what we got on the first procedure times 10 elevated to the decimals it has, and that times 10 elevated to minus 1 times the decimal it has. Basically, this formula is to don't have a lot of decimals, to round it to scientific method that I think it is called. And now, how we use these procedures on the app, it's hard to explain. Okay, on the first and second marker, the label tree, the one that says the distance is 10 kilometers right now, we set it that label to join the distance is that phrase, and the second procedure, it's in bit Africa. Okay. The second procedure, that is the one to round to decimals, the info input, we have the first procedure, we assign the marker 1 and marker 2 latitude and longitudes to the corresponding inputs, and then we tell the second procedure, the one of decimals, to 2 decimals, to only have 2 decimals. I have WhatsApp. Okay, nice. That we have it on both markers. It's hard to explain. You can see it clearer on our programming document, and it's pretty much it. It's hard to explain, but it works. For example, if I want something I saw with these maps, it's because of the cartography used, the map used especially. And our map is a road map. That's why we can see all the roads and political divisions. We assigned that on App Inventor. Okay, I'm going to grab, let's say, I saw this. This was weird, but I like it. To drag one, I think it was on this part of Asia. That here it says 25,000 kilometers, but if we go further, I think it's because of the projection it has. I don't really know why, and I don't know how to change that. We would like to know if you know anything about changing the projection used on the maps. But it's basically the distance is not so clear here. It's better for shorter distance or the equator distance. Okay, this was a wrap. It was it was hard to do it. We have to, I think, see, it was three tutorials, one for the location sensor, one for the map, and one for into mix both of them. We use the formulas used in shown in the class, and that's our innovation basically. Thanks for watching this video.